My first attempt at doing this video was so bad, I finally had to abandon ship and start over, so sorry this is being posted later than I thought. So what we've done so far in chapters 4 and up to now in chapter 5 is we've used maxima and minima graphs of polynomials. When we were looking at quadratics, we talked about the maximum and minimum of a quadratic. And now we're going to graph polynomial functions and locate their zeros. So the vocabulary that we're going to look at is the location principle, a relative maximum, a relative minimum, extrema, and turning points. And so let's look at this even degree function that has a lead coefficient that's positive because the end behaviors are both going to positive infinity. And if we look at relative maximum, we have one relative maximum point right here, if the calibration were right on my computer. And we have two relative minimum points right here and right here. All three of those points that I just marked are extrema because they're the maximum and the minimum points of a function. And they're also called turning points because it's at those points that the function goes from decreasing, and then it increases, and then it decreases, and then it increases. So those are the points at which the function changes, whether it's increasing. So graph f of x equals negative x cubed minus 4x squared plus 5 by making a table of values. Now you'll remember that I rarely want you to make a table of values by hand, but I do want you to know how to make a table of values in your calculator and to see how the graph relates to that table of values. So let's go into our calculator, and I already have put this function under y1, if I just take the select one. Now I really want to look at the table of values, and I think that some good points to pick for this is the x values that are starting at -5. I think that'll give us a good idea of where the points are happening. And the reason I say that is because if I look at the graph of this, all of the real zeros look like they're occurring between -4 and 2. So let's go to table second. So go to second and hit read. And that gives you the table. And so I want this table to start at -5, and I'm just going to have the change in table just out of every time. So that means the x values are going to start at -5, then go to -4, then go to -3, and show you the output values. So now to see the output values, go to second, and that's actually going to give you the table of values. This is why I don't really want you doing these tables by hand. We have tools to help with that. So what this table shows us, look between -4 and -3. When you plug in -4, you get an output of -4. So from that, we can now see that it's crossing the x-axis. We know that a 0 is occurring. Then let's look at again. And so when you get to -1, you plug in -1, you now have a positive value. We know that between -2 and -1, it has to pass the x-axis again. And then let's look at where the sign is. So 0 and 5, the actual value is 0. So at 1, we have one of our solutions. So if we wanted to do a quick sketch of this graph, if we didn't see the graph that our graphing calculator was showing us right now, we would look at our table, say, okay, we have a 0 between -4 and -3, and we have another 0 between -2 and -1, and we have another 0, well, right at 1. So we'll just put that one right there. What we have is an odd function, and it has a negative lead coefficient. So we know it's positive leading into this, and it's negative, it goes up here, and then the values stay negative for the rest of the time. So even though we're not sure exactly what this relative minimum is right here, or what this one is here, it gives us a pretty good idea of what this graph must look like if those are the three zeros that happen. If I now go to the graphing calculator and graph it, and we've done this before, you can actually calculate what those minimum and maximum points are. Trying to do that, just remind you, and right above here it says calculate. And we're going to go to calculate a So we're going to calculate this minimum value right there. So it always asks for the left bound first, and you can make the cursor go to the left, and hit enter. Then make the cursor go to the right of that minimum point, and hit enter. And so you see those two dotted lines. The next time I hit enter, it's going to actually calculate what that minimum value is. So at x is negative 2.6, so basically negative 2 3/3. Y has an output of negative 4.481. And so that minimum value is that Y value. So we have a relative minimum at negative 4.481. And we have a maximum, wait a second, calculate. And this time we're going to go maximum. And so we're going to go, we have a left bound and a right bound, plus that point. And so we have a relative maximum at 5. And those are the only extrema in this graph. Now the calculator will also calculate the zeros for you. And so go calculate and hit 2. And I'm just going to show you how to find the next 0. So go and hit enter. And then go to the right and hit enter. And the third time you hit enter, it'll tell you what the x value is of that 0. So negative 3.618. So that's one of the zeros. And then you would need to calculate the one that's between negative 1 and negative 2. And the other one's obvious, that it's exactly 1. So that's how you can use your graphing calculator to help you find these things. You should know how to do a table. You should know how to calculate the extrema. And you should know how to calculate the zeros of the function. Location principle. Suppose y equals f of x represents a polynomial function and a and b are two real numbers. And when you plug a into the function, the output is less than 0 or negative. And when you plug b into the function, the output is greater than 0 or positive. What that means is that the function has to have at least one real 0 between those values. In other words, if the outputs went from negative to positive, then it must cross the x-axis between those 2 points on the x-axis. All right, determine consecutive values of x between which each real 0 of the function is located, and then draw the graph. Well, you would go to your calculator again and put it in, and I put it and I'm going to show this one. And you can see the graph of this one down here in the right-hand corner, and it shows an even function that has a positive lead coefficient. If we look at that, we see that there are zeros that are occurring between negative 2 and negative 1, and again between negative 1 and 0, and again between 0 and 1, and again between 2 and 3. But to show that on the table would actually be really good. And so I'm going to do the second table set. And this time I'm going to have my table start at negative 3. And just to get a better idea of where the zeros are, I'm going to my half. So let's look at our table. So let's look at where the signs of the output values change. The sign changes between negative 1.5 and 1, so that gives us an idea of where that 0 is located, between negative 0 and 1. And we see that the sign changes between negative 1 and negative 0.5. And the sign changes again between 0 and 1/2. And if we keep scrolling down, we should see this sign more. And we see that it changes between 2.5 and 3. So we could write down that table and then sketch a graph from it. But if I sketch a graph and I'm just using the table shown right here, I know that there is a 0 that occurs between -2 and -1. And then again between 0 and 1. And then again between 2 and 3. So let's see, between 2 and -1, between -1 and 0, between 0 and 1, that's the one I forgot. And so we have 4 zeros that have to occur in this function. And we know for an even function that has a positive lead coefficient, it's going to be doing this, and it's going to be doing this. And so it's a matter of what it's doing in between those. So it has to cross the zeros here, here, and here. So that's a decent idea of what a sketch might look like for this graph. Determine consecutive values of x between which each real zero of the function is located. And we're going to use our graphing calculators for that. And so try this on your own and then see what solutions you get. So if I simply go by the table, I see that I have the output values changing. At -2, the output is -3, and at -1, the output is 1. So it has to cross the x-axis between -2 and -1. That's the only sign changing change that I'm seeing in relationship to the table. So if I were to quickly graph this, we have a 0 that's occurring between -2 and -1. And we have a cubic function with a positive lead coefficient, so we know the end behavior is going to be something like that. It might do something like that in between, but it's not going to cross the x-axis again, and there's only one real value. So we would say A, that there's one real 0, and it falls between -1 and 0. What you need to remember about odd functions is that it's going to be an odd number of real zeros. And for a cubic function, it'll either be 1 or 3 real zeros. So graph f of x equals x cubed minus 3x squared plus 5 and estimate the x coordinates between the relative maxima and minima occur. So this is one where you're going to do it in your calculator and actually calculate the values of the maximum and the minimum and show the x coordinate that goes along with that. So we have x cubed minus 3x squared plus 5. So go to y equals. I have that under y sub 3. Oh, so that's the one, is that the one we just did? So when we graph it, we see that. Now it's fairly obvious where the x values are, where these minimum and maximum occur. And if we look at the maximum point, the value of x where that's occurring is x equals 0. That looks like the maximum value is between 5 and 6. And then the minimum value occurs where x equals 2. And that is all that this one is asking on that. And so we can see that in the graph, and we could see that in the table that's produced. Now, just to go through and calculate these for sure, go to second calculate. So let's do the max of it first. So we'll go to the left of it, and we'll go to the right of it. And the third time we hit enter, it'll tell us that that maximum value is 5. And let's calculate the minimum value now. So let's go to second calculate. We're going to do the minimum. So left value and right value. Hit enter a third time, and we see that that relative minimum is 1, and it occurs where x equals 2. Don't be fooled by that x equals 1.99999. That rounds to 2, and your calculator does weird things sometimes, but use common sense and say that is 2. And there it shows that they were calculated. So why don't you do this one on your own and see what you come up with, and then I'll tell you what the answer is. When I look at the graph in my calculator, it looks like that, and we have a relative maximum that occurs at where x equals -2, and we have a relative minimum right around here that occurs where x equals 0. So you should have said relative maximum at x equals -2 and a relative minimum at x equals 0. The weight W in pounds of a patient during a 7-week illness is modeled by the function that, where n is the number of weeks since the patient became ill. Graph the equation. So you would use your graphing calculators to do that. In order to do this problem on a graphing calculator, we need to think about what our window should be, because we only need to see 7 weeks, and so we need our window for x's to go from 0 to 7, and we need to think about what's happening with our y values. We know that if we put at 0 weeks, we have an output of 110, which was the weight of the patient when it started. From there, we need to think about what our window should look like. So let's go in here and let's change our window. And let's say we have an x minimum at 0 for 0 weeks. And we have an x maximum at 7 for 7 weeks into the illness. And we'll make the x scale go by 1. So we're talking about a change in weight for this patient. We know that the patient's weight is starting from 10. But let's give that a little leeway. Let's assume that the patient is lighter than 100 pounds. And if it goes off the chart, then we'll know that the patient lost more weight than that in 7 weeks. We hopefully hope. Let's say I put in 120, because the patient probably is always going to weigh between 110 and 120 if the start weight was 110 pounds. So now let's look at this graph. We've made this into this. So where would you say it looks like the patient hit their minimum weight? If we look at week 1 is here, 2 is here, 3, 4, 5. It looks like around week 5, the patient hit their minimum weight. But let's go ahead and calculate it and see. So we second calculate, and we're going to calculate and find this patient's minimum weight. So we're to the left of it. Well, exactly where this patient is. To go towards here to the right of it, and then hit enter and see what the minimum value is. So it looks like the patient lost about 3.2 pounds during the course of this illness, and they ended up at a minimum weight of 106.8. And on the next page, it shows this chart. And so here is that minimum point where at 4 weeks, they hit a weight of 106.8. And so that's the relative minimum. So let's answer some questions about this. What trends in the patient's weight does the graph suggest? Well, it suggests that the patient lost weight until week 4, and then most likely healing began. And hopefully the patient didn't continue gaining weight as rapidly as this graph would suggest. Is it reasonable to assume the trend will continue indefinitely? Well, no, it's not. Just because the patient got better doesn't mean that they're going to exceed their original weight, until they hit like 500 pounds. That's not true. And so a good representation of this graph is probably from 0 to 6, where it shows the patient get back to their start weight. Most likely they're not going to gain more weight. All right, next is to check your progress, and so is that. So I think we are pretty much done with this video, and if you have any questions, just come on in and ask. Thanks.